Okay, everyone, welcome along to another Saturday session. Something slightly different this week. We're doing a sort of what if with Earth. So we're going to mess around with a few of the parameters on Earth and see what would happen if certain things were different with our planet. And we'll see how likely life is, and we'll see, what happens over a certain period of time. Should be quite interesting to see what happens. So here we go. This is on Universe Sandbox, of course. We have Earth here, and this is Earth right now. As we speak, as I record this, this is Earth right now, so we can see I'm just up here on the south coast of England, barely surviving in the low temperatures. So the first thing I'm going to mess with is rotation. So what we're going to do is we're going to mess with the rotation a little bit. So we want to go to rotation, and we want to change the rotational period. Now, let's imagine Earth is locked to the sun. So let's put it at 365 days. So now that Earth's rotation is 365 days a year, so basically one rotation for every day. Can we lock that? Oh, you can actually tidally lock it there. We'll leave it like that for the moment. And let's see what happens. Let's increase the time a little bit. Yeah, so this is going to affect things, isn't it? Because we're now at 1 hour a second. So let's put it to 1 day a second. There we go. And as you can see, it's rotating very slow. And look what's happening already. Already we've got a basin here in South America that's opened up with water. Anything else we can notice? Okay, let's move this on about 100 years and we'll see what happens. Okay, so here we are 100 years later, and I do not even know what this is, because that is not ice. Is that just pure cloud? One side of the Earth is completely ice. You can see up here, one side of the Earth is completely iced and one is covered in cloud. The average temperature is -7 degrees. That's got to be cloud, hasn't it? What's the likelihood of life though? 3%. A 3% chance of life. So we've basically destroyed life. So being tidally locked to the sun would be no good for us. Okay, this time we're going to speed up Earth's rotation. So what should we say? Let's say, no, let's put it at 100 times quicker. Oh my word, I haven't even advanced time yet. It's literally been a few seconds, and already at that rate of spin, look at what is happening to the Earth. It's going to blow itself to bits. The water is all collecting around the equator, which you'd expect because of that additional centrifugal force. Let's move the time on and see what happens after 100 years. Oh my word, it's blown itself apart. It blew itself apart after a few minutes, it looks like. What an absolute joke. So there you go, flat earthers. The second you start rotating Earth too fast, it's game over. So we effectively times the rotation of the Earth by 100. So that means it didn't rotate at 24 hours a day. It rotated at 0.024 hours a day, which is one rotation every 14.4 minutes. That is fast, and it's enough to blow the Earth apart. And look, you can see the core in the middle there. Total wreckage. Well, let's not make it as dramatic as that then. Let's just increase the rotation by 10 times. Let's pause the simulation. Let's increase it by 10 times. So now we're at 144 minutes. So just over 2 hours in a day here. Let's see what that does to the Earth. Clearly it was too fast before. Here we go. So we'll start it like normal first. Doesn't seem to be too many issues to start with. Let's go forward. Yeah, look, already the water is starting to pool around the equator, and we're not even that far forward. Let's start moving the time on. Okay, so we are now at only 6 years into the future, and this is the state of the Earth. Look at it. You can't even recognise continents anymore. All the water has pooled around the equator, and the likelihood of life is 63%. So, A lot of people would have died, but life is still possible. But that's only 6 years into the future. Wow. Okay, let's mess with something else. Okay, now I think it's going to be really cool if we mess with the Earth's mass. So what if we make it twice as big? Let's pause. We want to pause this because it's going to mess things up straight away. Let's make it twice as big as it already is, at double the mass. So not a lot has happened, and there doesn't seem to be any sort of changes. Even the surface gravity is only a little bit more than it would have been. So you know what that means. We're going to have to ramp things up. Oh, hang on a second. How far away is the moon now? That is a good point. Okay, let's really mess with this and make Earth 10 times the mass that it is. Now we might have an issue with the moon. Let's play the simulation. Oh, the moon is not happy. The moon is not happy. The moon has been blitzed apart. The moon has been blitzed apart in only months, but nothing else is really happening. The surface gravity is almost 3 times what it would have been now. Let's check now. So we're only a few months down the line here. The likelihood of life is only 31%. So that's had a huge impact on the likelihood of life. I assume that's just because of the extra gravitational pull. The moon has been obliterated. There's fragments all around the Earth. Dear oh dear, that really has messed things up. Let's go further into the future. Doesn't seem to be too much of a difference, but the ice caps are slowly working their way south. With Antarctica, it's not quite as bad, but it still isn't great. I mean, this is not good. And now we're 6 years down the line, and the likelihood of life is now only 28%. Okay, we're now about 12 years later. It's still 28%. It looks to be holding. So it's not great initially for Earth. The moon gets obliterated, but other than that, we can sort of survive that, I think. Some of us would survive that. So let's see what happens then if we decrease Earth's mass and make it 10 times less massive. Surface gravity is only 4 meters per second square. So that's over half less than it is now. Let's see how that affects life on Earth. Immediately, there doesn't seem to be many problems. The moon is that leaving? Is the moon leaving? I don't know. I think it might be leaving. Bye, moon. So we've lost the moon again. So both scenarios mean we lose the moon. Let's go further into the future. How dangerous is that moon going to be though when it comes back around? Okay, we're 5 years into the future now. Everything's looking pretty similar. How's life dealing with that? 31%. So again, making the Earth less massive has a similar effect to making the Earth more massive. The likelihood of life has gone down by about 70%, and we've lost the moon on both times. Not good. Not good. Talking of the moon though, I mean, what would happen? What would happen if we lost the moon altogether? So I've deleted the moon now. So let's see how life on Earth would deal with losing the moon. So just to show you at the start, likelihood of life is 96.8%. Now, let's move time on and see what would happen now that we've actually lost the moon, and that's the only change that we've made, losing the moon. How would that affect us? Let's have a look. Okay, we've gone forward about 5 years. Everything looks fine. The likelihood of life has dropped to 91.7%. It really looks like it wouldn't affect us too much, would it? I don't think it would. Okay, what about then? What about if we added moons? Let's add some moons. Now, let's put a moon that is a little bit further away than our moon. So let's put a moon about here. Let's put a random small moon closer, about there. Let's put another small moon about there. And let's see what happens. So now we've got a 4 moon system. So the Earth has 4 moons. Let's see what happens. Here we go. Okay, that one in the middle there is looking a bit sporadic already. I think we might have lost one already. I went a bit too far out. Or did I? No, we're okay. That looks stable. Oh no, what the hell has happened there? Oh my word. We've lost the moon. It just flew away. The James Webb Space Telescope is gone as well. There's the other moon up there. Nonk. Where's that going? This one is now very close to Earth. And we've only gone, right, so look at this. We've only gone a year into the future. Just a year in that 4-moon system. And we have a moon here that it's actually got closer to Earth. Let's look at the Earth itself. I'm sure the Earth itself looks fine. Yeah, no issues with the Earth itself. Let's have a look at the likelihood of life after a year of having 4 moons. 92.3%. Yeah, we could deal with a 4-moon system easy. Let's really ramp the speed up now. Okay, we're back to 5 years in the future again. We still have Gorsic orbiting us, and we still have this moon here orbiting us, which was, I think it's still our original moon. And we've lost 2 moons in 5 years. Earth is still looking pretty similar to how it's always looked, and the likelihood of life is still 92%. So I think we could deal with a multi-moon system easy. Okay, the last thing I'm going to mess with today is our tilt, our axial tilt. Now, I want to put it on its side. Hang on, let's pause the simulation. I want to put the Earth on its side to see what would happen. 90 degrees. There we go. So the North Pole is now facing the Sun. The North Pole is now facing the Sun. So let's see what happens. Speed the time up, should start rotating. There we go. Well, I would expect the Arctic ice to melt straight away. Here we go, let's move into the future. Okay, we're now about a year into the future. And obviously, as the Earth has gone around the Sun, a different side of Earth has faced it. And you can sort of see here, after only a year, the ice over Antarctica is starting to melt. So we can actually start seeing the actual continent. That's quite incredible. Surface temperature average is 7 degrees. Not a huge amount has changed there. The Arctic is still icy, I guess, at the moment because it's facing away from the Sun. The likelihood of life, 92.5%. So being on our side doesn't really kill too many people. I like that. I like that. It would work. It would work. Okay, there's one more thing I want to do. I want to change the distance that the Earth passes towards the Sun. So I've set this up now so that we're passing the Sun really closely on one side of our orbit, but passing the Sun really far away on the other side. Let's see what that looks like. We might fall into the Sun. Here we go. Here we go. Awesome. Look at that. Look at that. And we're going fast enough that we're not falling into the Sun. We're doing a little slingshot around the Sun and then all the way out to around Mars's orbit, look. And then back in towards the Sun. This is brilliant. I love this. Let's go forward about 5 years and see what life on Earth looks like after this. Okay, we're about 5 years into the future now. Oh my word, look at the state of... We've turned into Venus. Look at this. What is going on? The average surface temperature is now 179 degrees. This is not going to bode well for life. The chances of life are 1.79%. Oh dear. I've ruined Earth. Look at us. We're like a Venus. Love it. Absolutely love it. Anyway, guys, that is it for another Saturday session. I hope you enjoyed that one. Bit of fun messing around with Earth. If you'd enjoyed it, please do like, subscribe, hit the thumbs up, all of that. And I'll see you for another one soon. Thanks very much. Bye-bye.